Hello and welcome back to my Boost C++ library tutorial. In this video we're gonna take a look at the first Boost library, the Accumulators library. Now the Accumulators library's purpose is to be approximately right, that is better than exactly wrong. Well, yeah, that's basically what the idea of this library is. Now, this library implements accumulators for statistical purposes. So in general, what the idea of the library is that you are creating yourself a accumulator set and you're pushing data in the accumulator set, and then you're gonna get some details out of the accumulator set. Okay, so let's maybe implement this and also find a bit of a use case what this could be purposeful and what this could be used. Now, let's imagine inside of your application you implement a web server, right? So you're gonna have some code, so start a web server. And basically what you're doing is you're running a web server. And what happens at some point, that is, you have a function that calls let's call this function on request. So you have a function that is executed on a request where you are parsing the request. So you're parsing a request. Then what you're doing is you build the response, and what you do is you send the response. Now this could be a very, very simple web server that you are implementing on your application. Now what you might want to do is you might want to get some insights on how long this request handling takes, and you might also want to know where this request handling takes. So let's just imagine that you are now trying to kind of like find out how long your routes take in a certain profile mode so that you can have some insights what's going on your web server. So what you're doing is you're defining yourself a accumulator. So you're defining yourself an accumulator. For the accumulator, what you're needing is of course Boost. So you need Boost, accumulators are HPP, and what you're using is a Boost accumulators, and what you are using is an accumulator set. Now first of all you need some value that you want to kind of like accumulate. In this case we want to accumulate a double value, since we are trying to find out how long requests take, and we have our requests and they are like calculated, let's say in milliseconds, and stored as a double value. And now what you need to do is you now need to specify what kind of like metrics are built. Let's maybe format this a bit different so that we can get a bit of insights on how this is going on. And let's add a Boost accumulators stats object. Now this stats object basically indicates what the accumulators use. Is it really stats? Was it called stats? Stats. It's coming from statistics set stats. Okay. So let's include statistics stats. So this is the header that is required. Now, in general, what is relevant if you want to know how your web server is performing? So first of all, what you need is a count. So you need to know how many requests have been taken into account in your accumulator. So what you would do is you would use a accumulators, and then I think this is called tag. So tag and count. This is what you want to have as a metric. So you want to have a count. How many requests have been taken? Then what you might want to know is you might want to have to know what the maximum request time was. So what was the worst case that this request was executing? And also what you might want to have is you might want to have the mean. So you might want to have the mean value. What is the average time it takes for one request? And then you might also want to have the variance, so that you know kind of like what the standard. I think maybe is there a derivation, weighted density. Let's just stick with the variance today. I'm not a statistics guy. I'm not too much as a statistics guy. I also need to take a look into what statistic values are right to kind of like get a good insight on what's going on. So yeah, basically what you would do is you would define yourself a certain accumulator type. I'm not too much of a fan of using namespace globally, so what I tend to do is I just tend to define myself an accumulator type, and yeah, go for it. Now, on a request, you might have multiple things, right? You might have a std string. I think we don't have string included, so let's include a string here in there. So let's maybe on a request add a const string reference and call this one route. You have the route that's been processed, and currently I'm just gonna also gonna give the double delta t. Of course, what you would do is you would kind of like start timer. So you would start the timer here, and then what you would do here is you would stop timer. So start the timer here, then you would parse the request, build the response, and then before you send this to asynchronous IO, you stop the timer and basically tell how much time has elapsed. And then what you would do is you would go for example, let's say an unordered map in C++, and then you would have a, let's call this one static std unordered map, and you would have an unordered map of an std string to a accumulator. So this is basically what we would have, and then we would call this one like stats. And what would happen inside of your request method is that you would go, and basically what you would do is you would run the accumulator for the time that has evolved. So you would kind of like add to the accumulator. Now basically how the accumulator works is that you can execute the execute operator. I think maybe there's also a more explicit way of doing that. I'm not sure. But in general, like if you have an accumulator here, I don't really see some intelligence on this one, but what you can do is you can use the bracket operator to push some data in it, some values in it. In this case, I am pushing the timer value in here. Normally, this timer value would come, from the actual timer while the function is executing. But now, in this case here, I would basically, for profiling and testing purposes, just insert a random time here. And now you would basically have the stat here. So let's now simulate that the web server is running. So maybe let's use a let's make just the size ti, and let's just maybe run this 20 times, and then I'm going like I++, and if I equals 0, so if we are at the serious page, then I just call for one my request for index, and I'm just gonna say like the first take took like 20 milliseconds, and then I also have like a route called imprint that take also like, let's say, because it's a bit lesser, it's like 10 seconds. And else what we're gonna do is otherwise we're gonna say something like, let's say 5 milliseconds, plus I want to add some random value. How can I add a random value? Let me just add I divided by, it's not a random value, but it's like increasing, let's say I divided by 3 to it, just that I can simulate something that's going on to that route. So just some random value. So what we would do is, this is just simulating the web server, and then what you can do is you collect metrics. So in this case I'm gonna do for auto reference accumulator in my stats. I'm just gonna go through, and then I'm gonna just std out something, and then I think cout is not in here, so let's use IO stream here, and then inside of here I think we can add a using namespace Boost.Accumulators. We can use it in here, and then what I want to have is my first, so I want to have like the name of my statistic thing, and then what I want to have is the count, max, mean, and variance. So maybe let's only run the imprint half of the time. So if I modulo 2 equals 0, so only then I maybe run the imprint call, so that we can see a bit of difference. So let's maybe add a count in here. So how to extract them? We use the count method on the second. So on the accumulator we are using the count method. In this case, this is now a so-called extractor. The extractor is defined by Boost. Boost.Accumulators extractor. It's just defined by the name, like count, max, mean, and variance. So let's maybe do something and say, okay, this is kind of like the average value. So the mean of the accumulator is that one second. Let's maybe now try to format this a bit at least, so that we have these and these. Okay, so now we have the mean value. What do we also have is the max. So let's maybe add a plus for the this one stays the same. So let's add the maximum value that we have, and then we have the variance. So maybe let's make it as an equal in here, and then for the variance, maybe let's say this is the variance, and then we add the variance. So this is basically the code that I've implemented, and this should give us now a bit of the metrics of our simulated web server. And if I run that, oh, there's one thing missing, std end line here, let's rerun this now. And if I rerun this with this accumulator, let me bring the console into focus, you can see that we have index and imprint. You can see index has run 10 times, while the imprint has only run 10 times. You can see that the mean value of the index was 8.6 milliseconds on how it ran, with a variance of up to 10. Oh, we forgot a bracket here. That's not cool. I need these important things like brackets, right? And you can see that the maximum time of the index was 20 milliseconds, while the maximum of the imprint was 10 milliseconds. So what you can basically see is that these accumulators, they allow you to define a certain statistical analytics of a value. In this case, it's a double value, but I think everything should work, right? If I would have my struct tm class, I'm not sure which contract needs to be fulfilled by the first parameter of the accumulator set. The first one, I'm not sure if I can find. If I can peek in here, you can see, yeah, it's called sample. I'm not sure what the what a sample really needs to fulfill of a contract to be considered a sample, but we don't want to go too much into the details, right? This shall just be a quick overview on how this library works, right? So just adding random values and going in and accumulating values together. And in the end, what you get is you get a bit of an insight of what's going on, right? And if you would write a web server, you could actually do it. I'm not sure how accumulators work in terms of multi-threadability. I don't think that they are by default guarded, so you would need to also make sure that they are not accessed by multiple threads at the same time. You could do this by basically having, maybe this is some aligned allocated structure or something, or some guarded structure, so you could have a guard around the accumulator, like a mutex or something, so that the accumulation works in the proper way, and then you just initialize the map at startup with all routes that are possible on the web server, and then during running you can always access a map without having the problem of a race condition if you're just like accessing it and reading data from it and taking a look what's behind it. And the accumulator is guarded, and you accumulate on top of that guard. And then you can get like these metrics and these insights of the routes. And this is especially important if you have like a web server. And I think you can also reset the accumulators at some point. I'm not sure how this would work. If I go like for accumulator arc, I'm not sure. Can I call reset or clear? Is there a clear method? I'm not sure. We would need to take a look at this. IntelliSense and Boost is also a quite interesting story. It doesn't really work, but what you can always do if you want to see how something works, you can open it up and try to find something. This is a constructor. This is a constructor. Boost is, again, it's a big library, but yeah, you have a visit function, visit if. This is the operator. Another bracket operator, another bracket operator. I'm not sure how it works. This is like all drop. Maybe there's no way of clearing an accumulator, which is not too big of a deal, but you would just need to make it sure that you are reinitializing it. It's of course always possible to reinitialize an accumulator, I think. Like in the end, it's a really handy library for getting a few metrics out of your application, right? It's super simple. For web server, you're writing this accumulator, you're accumulating to it, and then you can display some stats in some developer dashboard of your web server. And you could also even have a switch to like enable and disable profiling on your web server, so that it's only accumulating if you really need to. But this is, I think, something, some really unique and also, I think, some really useful feature of the Boost library that we are directly getting into, these accumulators, which is kind of nice. And if you actually want to know what statistical properties are available, you can actually take a look at the homepage, and you can find an information on this. Let's go back maybe a step. and then go to statistic library reference. So there you can go like count, covariance, density, error of mean, extended p-square, kurtosis, max, mean, median, min, moment, the moment, pot, quantile, rolling count, rolling mean, rolling sum. There's a lot of stuff going on. You could also have like sum is, I think, also quite an interesting thing that we could have, right? To know the total computation time spent on one route on a web server, right? This is also how it is, right? If you want to extend something, just add the sum in here. Add the sum to the list, and now you have a new metric to the system. So I could add something like equal, and then you could extract the sum of accumulators second in this case. Right? It's as simple as that, and now we should have a sum integrated. The total processing time that we took there, yeah, 127 milliseconds and 48 milliseconds. Like, this is the whole idea. You can just describe what data shall be accumulated, and then you can always access it. And for web server, if I would have something, I would definitely enable like some profiling option that would help. And then you would do something like static bool profile as by default false, and you would do something like if profile, then do that, then you're profiling, and in this case, well, I do enable profile, and then if I enable profiling, I'm gonna get some values out of that. I'm not sure if the accumulator is actually, if I should be initialized by null values, by 0 values, so if I get some information out of the accumulator is not running, it does give me nothing. It seems like it crashed. Did I have an exception? Ah, no, of course. There are no accumulators currently present. So what I would need to do is I would need to make sure that the accumulators exist. But on request, I think, yeah, I can see I'm implicitly creating them here. This is why it doesn't work. But we can get around with this by doing like an auto reference accumulator equals that, and do like act this. And if I do it like that, then we should at least have the accumulator ready, and now it should give us 0 values. So now you can see it's not 0, right? You can see 0 and then it's none, so minus none for the maximum value, not a number, so minus the most negative number undefined, 0 0 also here, plus the maximum value. It's also this, I think, yeah, it's like some undefined values that indicate that there are no values inside the accumulator, which might give you some odd numbers. So you should always have like a 0 line that is presented once, maybe. But yeah, you could also, of course, track it. I think it would be nicer than like how I've done that, so that the accumulator is not existing. If you're not profiling, then the object is not in existence at all. This is, I think, the more cleaner way of doing it, so that you have nothing. And as soon as you say, all right, well, let's start profiling now on the web server, then you set it to true, and boom, what you get is you're getting your profiling values out of the box. And you can get some insights. And then, of course, if you're writing a web application with C++ and you have these accumulators in place that give you a bit of stats, then you're gonna get, of course, some informations. Of course, it's not everything that I would in profiling. In profiling, for me, the accumulator would be only one thing. What I would also do is I would also try to get some samples, or you could even use the accumulator to get samples. So maybe if you were doing this like that, the accumulator would run like that, and then what you would have is something like void. Let's maybe call this one as cycle. Void, let's call it cycle 1s. So you have a function that is kind of like triggered every second, and every second what you're doing is you're going for your accumulators in the stats, and what you're doing is you're extracting just the mean and building like a chart, right? For example, you could have a static std list of double, which is called charts or chart. Let's call this one chart. And actually what you would even have is would have something like that, but instead of a list you would have that. And then what you could do every time this is called, you would first go to that one, and then you would say second, and you would say using namespace boost accumulators. And what you could do is you could do something like mean and extract the mean value and add this to there, but of course we're not assigning that. We're going to push back this value, and then basically what you do every second, you would take the mean value, and then you would also get some chart. Of course the mean value is maybe not the best one because it does not really implement the mean. Maybe the moving window. I think there's also, where did I saw the rolling window? I think the rolling mean, I'm not sure what the rolling mean really is, but there are of course some statistical values that are better for the mean to kind of like get information out of that. Maybe with a window that is only taking into account a certain window of values. Like, I'm not sure if there's something in here, but there might also be some statistical value that is kind of like filtering away spikes and would be more suitable to building like a chart. And then of course for the chart I would more use like a ring buffer for the chart, so that you have like a ring buffer of the stats of the last, let's say 60 seconds or something, depending on what you want to have as a metric in the web server. There are also more libraries on Boost that would need to really help you building a sophisticated way of handling such metrics, but this is like a starting point, right? You have a list of accumulators, and you have a list of values for charts, and then you have like your on request method that's called in a request, and then in your main loop every second you would trigger like the cyclic interrupt that would iterate over everything and extract, for example, like the mean value to get the current mean value, and then you could somehow put this into some statistical API of your web server. You would have like a system API of the web server, so like a route that is of course also tracked by this one. Kind of funny, but it would be. And then you would have like some route like for example like system, or let's say __ system API stats or route stats route equal, and then you would specify like a route, for example this like index, or like any route. I'm not sure how does it actually work. Can I have slashes after the question mark? I think yes, in HTML, like imprint. And then you would get, for example, like some JSON stuff, and it would say something like max, and then there's like the maximum value of like 20, and then you have a lot more JSON, and then you have like samples, or have like the chart value, and the chart value is like an array, and inside of that array you would have like 0.3, 0.5, and you would basically have a list of things, and then from this JSON information from the system API you could have something like server admin or something like that, and then like stats or route stats, and then you would have maybe something like that imprint, and this would query the API and present the UI that gives you some insights on the server's statistic and render all the data. And this is kind of like a very, very common use case on how you could define that. Maybe you would even have that like that. Server admin. I think you would more do it like that, so that you have like the system route and then server admin route stats and things like that. That would give you then like HTML, some HTML and JS, and the JS would call the API and then display this via JSON on the page. And then you would already have built yourself a nice little stats API that you as a server admin can look at and then see which routes are performing well. You could also of course have some more sophisticated things like not maybe route state, something like hot routes, or yeah, let's call it hot routes, and then you would get some HTML and some more metrics in behind that check all routes and then give you the top 5 routes or something like that take the most time, depending on some inputs, like for example hot routes mode total would give you the total routes that are accessed, like total time, or like the mean, the calculated computation time per route, or yeah, to kind of like give you some insights. These are just some, I'm just like joking a bit around and just like trying to present you some ways on how you could use that to get some insights. Of course, this function is now not called and might get warnings, of course, because the function is not called maybe. But in the end, what I'm trying to do is I'm just trying to give you some insights on how this could be useful. I think these accumulators are quite useful, especially for like statistical things. And if you combine them with other Boost library features, you can already get quite far with Boost. And yeah, that's the whole point, getting you to the Boost library. Okay, I think this is enough. I've talked now quite more than I've actually programmed, but I think this is important that you understand what the power of these is and how you could, for example, use these. Because if you just want to get information about these, you can also look at the documentation yourself. But I want to kind of like bring it a bit closer to you. Okay, so thank you for watching. See you in the next video. Make sure to like and subscribe and have a nice day. Bye.